Good afternoon, everyone, and welcome to WASA Distance Education. This is Foundations for College Mathematics, Grade 11, College Preparation, and my name is Marvin. Welcome to the 14th class of the term. My contact information listed on the screen, marvin.osmond@nnacschools.org, or my personal cell phone number is 807-738-2031. Feel free to text or call or email, whatever is more convenient for you. Just want to remind everyone that we are starting lesson number 7 today on compound interest. If you have completed any of the lessons to date, so lessons 1 through 6, if you've done any of those, please get them to me as soon as possible. Either scan and send them directly to me or go see your DEC in your local community and have them get it to WASA, and then they can get it to me. When I get them, I typically mark them the same day that I get them and get them back to you either the same day or the following day so you get immediate feedback. That way, if you are making any mistakes, if you're not quite sure about something, we can catch it early and make the corrections so that we don't continue to make the same mistakes repeatedly. So yesterday and the day before, we looked at the simple interest and the simple interest formula and how to calculate the amount um, in an investment or the amount of a loan that you have to repay. So that was simple interest. So what I want to do now is just go back up and just do a little bit of review on that. Can't go through the key questions, but so here there's some support questions. And I just want to give you some pointers. The way that I do them is I always start off with, and I'll just come up into here and I'll tab over and or this is going to be the solution. I always start with given. What am I given? What do I know? Okay. So what do I know? And that comes right from uh, the sentence itself or the problem itself. Okay. So what do I know? So we're dealing with simple interest. So we're going to be dealing with the simple interest formula, I equals P times R times T. Okay, so this is what I know. And then my solution will be done over here. I'm just going to scroll back up just to see how okay. Okay. Let's take a look at some examples here. So in this particular one, it says that Troy had an outstanding balance of $1,236.90 on his credit card. So the balance, that's what we started with. So that amount here is the principal amount. That's the amount we are starting with. 80 days time. And then the 18.2% per year is the interest rate R. Okay. So we're going to be using I equals P times R times T. So let's start with the principal. P is equal to 1, and I like to do 1 comma 236.90. And I like to do, so I usually put them in order, P times R times T. So R is equal to Now, 18.2% has to be converted to a decimal. So that I need to take the 18.2, divide that by 100 to get 0.182. That should be, and again, this is because I'm using a word processor, it automatically wants to capitalize everything. And then T is going to be equal to, now 80 days. So T has to be a fraction of a year. So what I'm going to do here is to insert an equation, uh, and we'll do it this way. So T is equal to, you decide here, T equal to, and we're talking about months, no, sorry, days. So it's going to be 80 over, and there's 365 days in a year. So that will be 80 over 365 years. Okay. So now we simply, the solution is going to be I equals P RT. So now all you have to do is do the substitutions for P, for R, for T, then do the calculations. And we did several examples like this over the last couple of days up here. So here is the givens, here is the solution, and then you're going to use A equals P plus I to find the amount, and then you are going to write a statement. Okay, so that's what you're going to be doing in all of these right here. Okay, you can be following the same step all the way. So what I want to do now is get rid of these little marks so it's not as messy. So now do the substitutions, then over here. Now, in this particular case, we only have to find the amount of interest, so we don't need to find A. So once we've done this part, we're done. And then it's just a matter of writing a statement over here to answer the question. So I would do all of these the same way. Start with given, and I'm not going to do all of these for you. So, and again, it's a good habit to get into. Start with what you're given, then do your solution. Start with what you're given, and then do your solution. So write out what your P value is, if you know what it is, what your R value is, what your T value is, and then do the substitutions. And again, here, don't forget to write a statement. Okay, so that is it pretty much for simple interest. So, and again, it's not used by many financial institutions anymore. Most people now use compound interest. Okay, so I'm just going to take this out for now, and then we can move down and get ready for compound interest. Okay, so compound interest, we refer to it as interest on interest. So we're going to solve problems, and we're going to use the compound interest formula A equals P times 1 plus I to the power of N. Now you're going to need a scientific calculator for this because we're going to be dealing with exponents. Because we have a variable in the exponent, these graphs will be exponential graphs. Simple interest didn't have any power, so we had a linear relationship. Here we're going to have an exponential relationship. You'll see what the graph looks like a bit later. So A is the amount at the end of the period. That hasn't changed from the simple interest formula, A equals P plus I. Now, in the simple interest formula, we did the calculation where we found the interest first, and then we find the amount after. Compound interest, we do it backwards. Here we're going to find the amount first. So how much is the investment worth at the end of a time period? And then we're going to find the interest after. So we're not doing the interest first, then the amount. We're doing the amount and then the interest, amount of interest. Okay, so it's a little bit backwards. So this formula A, so in the simple interest, we started with I equals P times R times T, and then we want A equals P plus I. Now we're going to do A equals P times 1 plus I to the power n, and then I is equal to A minus P. So we talked a little bit about this yesterday. We got started. So I'm going to scroll down because there's lots of examples uh, in the material you would have received, but I want to go down and add some new notes. Again, this is in blue, so this is not included in your package. So if you're watching the YouTube channel or the video later, then this material is new. So just some more material, hopefully help clarify some things. And I'm going to work through some different examples with you that are not included, so you have more examples to guide you through the support and key questions. So compound interest is calculated on the principal amount and the accumulated interest of previous periods, and thus is regarded as interest on interest. Interest is commonly calculated or compounded at regular intervals. These intervals can vary. So below is a list of the commonly used intervals and the number of times per year interest earned on interest is calculated. So compounding period. So what you'll see in a lot of problems is interest is calculated annually or semi-annually or quarterly or monthly or semi-monthly, weekly, bi-weekly, or daily. So those are the most commonly used compounding periods, and these are periods per year. So annually means you're going to get one interest period per year. So at the end of the year. Semi-annually, annually means twice per year or two times per year. So at every 6 months. Quarterly will be four times per year or every 3 months. Monthly is 12 times per year, so every month. Semi-monthly is 24 times, so usually the middle and the end of the month or the beginning and the middle of the month. Weekly is 52 times per year. Bi-weekly would be 26 times per year because that would be every 2 weeks. And daily would be 365 times per year, 365 days. So the more times it's compounded per year, the more interest you'll earn. So if you have an investment, you would like it to be compounded daily. If you borrow money and you have to pay it back, then you probably want to have it compounded annually or only once per year. Now, of course, the interest is, or the number of times the interest is compounded is only one factor. The interest rate itself is another one. So usually it was compounded multiple times per year, it will be lower than if it were compounded once per year. So there's different circumstances, and each one will determine how much interest and how many times it's compounded. To calculate the amount of the investment at the end of a period, we're going to use the formula A equals P times 1 plus I to the power of n. The A and the P represent the same thing they do in the simple interest formula. A is the final amount, and P is the initial principal. So the amount you start with is P, and the amount you have at the end of the period is A. I, in this case, not R, I is the interest rate per period and also has to be expressed as a decimal, just like it did in the simple interest formula. And n, not t, n is the number of time or the number of compounding periods in total. So we have to do some calculations here before we actually use the formula. And then to find the amount of compound interest earned, then we use the formula I equals A minus P. So you'll notice that in the simple interest, found the interest first, and we A equals P plus I. Here we're going to find the amount first and then find the amount of interest after. So it's a little bit different. We'll work through some examples and you'll see the difference as we work through them. So the first problem, 7.1, the first sample problem, it says determine the amount of each investment, then the amount of interest earned after the given time periods. So first one is $3,000 invested at 4.5% per year, compounded monthly for 7 years. So you see the word compounded monthly, that means it's a compound interest problem, which means we have to use the formula A equals P times 1 plus I to the power n. So as soon as you see compounded monthly, we're dealing with compound interest. If you don't see that word compounded, then we're dealing with simple interest. Okay, so that's how you determine what type of problem you're looking at. I'm just going to put this down here a little way so we don't see it right away. So if I were to look at the formula, the amount of the initial investment, $3,000, that would be the initial amount. So there is my p-value. We are talking about 4.5% per year compounded monthly. Monthly means 12 times. So actually, just get it means, I'm just going to get rid of this, 12 times per year. Okay, so 12 times per year. Okay, so what we have to do, because we are compounded monthly, now we have to divide the 4.5% per year, because that's per year. We need to know what it is per month. So we're going to be dividing that by 12. Okay, and we're dealing with 7 years, so that would be the t value, but we're not interested in t, we're interested in n. So when it come down here, we have to do the calculations for I first, because we don't know what I is. So I is the interest rate, which is this 4.5% as a decimal, which is 0.045. Divide that by 12 to get 0.00375. So that's the I value. N is the number of interest periods or compound periods in total. So we're doing it 12 times per year for 7 years. So that's 7 times 12. So my N value is 84. So now I'm ready to use the compound interest formula. A equals P times 1 plus I to the power of N. I know what P is. I now know what I is. I now know what N is. So now it's simply a matter of doing the substitutions. So we have 3,000, which is P, times 1 plus I is 0.00375 to the power of N, which is 84. So 1 plus 0.00375 is 1.00375. So now, order of operations, we are multiplying and we have an exponent. So we have to do the exponent first. So now we have to do this part first. Oops. Oops. We're going to do that part first and then multiply it by 3,000. This is why you need a scientific calculator. If you have a regular calculator, you have to go 1.00375 times 1.00375 84 times and not make a mistake. It will take a long time. Okay. So what you need to do is get a scientific calculator. You're going to type in 1.00375 y to the power x 84 equals you get 1.369452257. Don't write that number down. Leave that number in your calculator and then times that number by 3,000 times 300 and you'll get 4,108.35677. We're going to round it to the nearest penny. So 356 rounds to 3.6. So we're going to end it with the amount of the investment after 7 years will be $4,108.36. So we started with 3,000. We now have $4,108.36. How much interest did we earn? So the interest earned here is the amount that we end up with, which is $4,108.36 minus the principal amount we started with, 3,000, and we get the interest is $1,108.36. And what I like to do, because it's the last step, so I'm going to put in the dollar sign, and I'm going to put in the dollar sign here because that's what we're dealing with. Once we've done that, now here we're just doing the calculations. It says determine, and it's not asking a question, so it's okay to leave it as such. Okay, so what I'm going to do is erase all of that for now. So if you are watching this, you can obviously pause, rewind, fast forward, but I'm just going to get rid of all of the marks so that uh, it's if I need to send this up to someone at a later date, it's not all marked up. I just did this to illustrate what we were doing as we were doing it. But if I send it up and you're not watching the video, it's not going to make a lot of sense probably. Okay, so there's one problem. We'll work through a few more just so you have some examples to follow. Okay. The next one, and we'll just, I'm just going to move, oops. For now, I'm just going to move this down out of the way, and we'll pull it back up later. So we're just going to, before we start the solution, let's look at the problem we have. And let's determine what we're given. In other words, what we know. And then what are we asked to solve? So here, the 12,000 invested, that's what we started with. That is the p-value. This is the interest rate, R, but we're not interested in R. We're interested in I. But this is 3 point, so 3.25% would be 3.25%. And to convert that to a decimal, you simply divide by 100. And you'll get 0.0325. compounded daily, which means it's going to be 365 times in a year, and for 2 years. Okay, so now when we scroll down here, the I value, remember we have to do the calculations now. The I value is 0.0325 divided by 365. Now, if you do that, let's do it. 0.0325 divided by 365, you'll get a very small number. So it's going to be 0.00008904109589. A very long decimal. So what we're going to do is we're going to leave it and not write it as uh, a decimal. We'll leave it as a fraction for now. N is a number of compounded periods in total. 2 years times 365 give us 730. So I know what I is. I know what N is now. So now I'm ready to use the formula. So what I'll do now is, for now, is erase this because we've already, oops, why is it? Let's get rid of this so we can move things up again. So we now know how we arrived at our N value and our I value. So we can eliminate this for now. So we've done that. So now we can do the calculations. So I, we know as a fraction, leave it as a fraction. So the formula A equals P times 1 plus I to the power N. And again, whenever we're dealing with formula in mathematics, the first step in the solution after you've done your I and N value is to always write down the formula. Okay, so never do a problem without doing the formulas first. So A equals P times 1 plus I to the power N. Do the substitutions. We know the P value is 12,000. There's the P value, 12,000. 1 plus I, we're going to leave I as 0.0325 over 365. And then to the power of 2 times 365 is 730. So that's a really big exponent. So to do that without a scientific calculator is going to be pretty difficult. So when you're doing these, what you need to do is do this part first inside, because we have to do what's inside the bracket. And inside the bracket, we have addition and division. So we need to do the division first. So let's do that part now. We're going to go 0.0325 divided by 365 equals. So now that we've done that, we can do the addition inside of the bracket. That's plus 1. So everything is done in the calculator. So don't write anything down. We do all this in one step. So now we have exponents and multiplication. So we have to do the exponent first. So now we go to the power of 730. And then we need to times that by 12,000. Again, we're following the order of operations. And I get 1,201, sorry, $12,805 0.87124. So round that to the nearest penny, which means two numbers after the decimal. It works out to be 1,000 or $12,805.87. So what I would do if I were you, and you may be not used to doing these sorts of problems, I've got lots of examples. So sit with your calculator and work through on your calculator all of the calculations that I did for A and I to make sure you're getting the same answers that I'm getting. If you're not getting the same answers that I'm getting, then you're probably making a mistake on how you enter the numbers into the calculator. And depending on the calculator, things might be done slightly different. So if you're having trouble with the calculator, give me a call and I can walk you through what to do depending on which calculator you are using. So now that we've found the amount at the end of 2 years compounded daily, now we need to find the amount of interest that was earned in that 2 year period. So I equals A minus P. We just found A, $12,805.87 minus the principal. The amount we started with was 12,000. So the amount of interest you earned was $805.87. Okay. So now we're going to work through, I've done an example of each one. So compounded monthly, compounded daily. Now we're going to do a problem that involves compounded annually. So again, we need to do the calculation for I. I is 3.6%. Now to convert that to a decimal, we simply divide by 100. Okay, so 3.16 divided by 100 is 0 point. We did it right here. That should be divided, yeah, by 100. 0.036. Compounded annually means one time per year. So we're dividing that by one. That's why I divide by one. And any number divided by one is itself. So 0.036 is the I value. One time per year for 4 years. So n is 4 times 1, which is 4. So now we're ready to use the compound interest formula. So it's now simply a matter of doing the calculations or do the substitution first. P is 19,500. 1 plus 0.036. We can do it as a decimal here because it's just a nice, short, simple number. To the power of n was 4. So 1 plus 0.036 is 1.036 to the exponent 4. So again, take out your calculator, and I'm going to do it again just to make sure I've got it right as well. So 1.036 to the exponent 4 times 19,500. And I'll get, okay, I made a mistake here. So 19,500. Nope, clear that again. I'm going to go inside the bracket first. So 1.036 to the exponent 4 times 19,500. And I'll get $22,463. And then it goes 0.303. So round that to the nearest penny would be 0.30. So I'm checking to make sure that the answers that I'm getting are the same answers that is here. So now I'm pretty sure that what I've done is correct. And then I equals A minus P. So the 22,463.30 minus 19,500 works out to be $2,963.33. So again, I'm getting rid of all these black marks just to tidy this up a little bit. So now we've done 3 of these, and we've done compounded monthly, daily, annually. So now we're going to do 2 more, one compounded weekly, which we haven't done, and then compounded semi-annually. So that will give you 5 examples. And depending on the problem that you're trying to solve, you come back up and pick which one is just like the one that you're doing. So if it's compounded weekly, you'll use this example right here. So in the compounded weekly one, I'm just going to just get this down out of the way so it's not in the way as we're working through it, so it's not confusing us. 26,775 is invested. That's the p-value. 10 point 7% divided by 100. That gives you the 0.107. Compounded weekly, there are 52 weeks in a year. So that's why we're dividing by 52. So I equals 0.107 divided by 52. That's going to give us a really long decimal. So we're going to leave it as a fraction. 3.5 years. So that would be 3.5 times 52 weeks in a year gives us the end value of 182. So now we have I, we have N. So now we are simply going to go in and do the calc. So first, formula, A equals P times 1 plus I to the power of N. Now do the substitutions. P, we said, was 26,775. 26,775. 1 plus I is 0.107 divided by 52, all to the exponent 182. So we have multiplication, brackets, exponent. When we have brackets, we do what's inside the brackets first. Inside the bracket, we have division and addition. So we have to do the division part first. So we're just following the BEDMAS rules or order of operation rules. So 0.107 divided by 52 equals 0.0020576923. Leave it as it is. Don't touch it. Now do plus 1. That gives me 1.0020576992. Now we have to do the exponent. So to the exponent 182, 182. We now have a number 1.453704644. Now times that by the principal amount of 26,775, and I'll get 38922.94184. Round that to the nearest penny, so 941 rounds to 94. So we end up with an amount of 38,970, sorry, $38,922.94. To find the amount of interest, you just go A minus P. So 38,922.94 minus the 26,775 we started with, end up with an interest amount of $12,147.94. So I'm going through these fairly quickly, but they are laid out step by step in here for you. And again, this is blue and red, so this is new material that's not included in the package you would have received. So if you're watching it, you're seeing it. And if you're not watching it and you want to have a copy of this because I save it, then let me know and I can send it to you so you can have a copy for your reference. Okay. So now we have just the one left to do. So we've done weekly, we've done annually, we've done daily, we've done monthly. So we'll do one more semi-annually. So again, 35,000 invested. That's the P amount. Okay. 3.34 is 3.75. And to convert that to a decimal, we simply divide by 100. So 3.75 divided by 100 is 0.0375. Semi-annually means twice per year. So we're dividing by, that's where the 2 comes from, dividing by 2. So this number divided by 2 is, now we're not dealing with a strange and very long decimal this time. We have 0.01875. So we'll use that value instead of the fraction. If you want to leave the fraction, that's fine too. So we're compounded semi-annually twice per year for 5 years. So 5 times 2 is 10. Now I have N, I have I, simply a matter of doing the substitution. So the p-value here goes over here, 35,000. 1 plus I is 0.01875 to the exponent 10. Again, we're going to follow the bedmass rule, so we're going to do the brackets first. Inside the bracket, we're going to go 1 plus. So let's do that now. So let's do 0.0375. Divide that by 2 and get 0.01875. Add on the 1 to the exponent 10, and then times 35,000. And I get 42,144.82568. 0.825 rounded to the nearest penny is 0.83. So the amount at the end of the 5-year period will be $42,144.83. So the amount of interest that we are going to earn in that 5-year period is going to be 42,100 and sorry, $42,144.83 minus the amount that we started with of 35,000 to get the amount of interest of $7,144.83. So we've done 5 examples, or I've done 5 examples for you. Again, uh, this is new material. So if you're not on air with me and you're not watching the YouTube video, then you're not seeing this. So if you do want to see it and you don't want to watch the YouTube videos, then you need to contact me and I will get you a copy of this. I can email it to you. Now, these files will be fairly large, so it might be tricky to email it to you depending on what your internet speed is. So I might have to send it to your DEC at the Learning Center. Their internet might be better, or we may have to send up a jump drive with all of the material on it. So either way, if you want a copy of this, then I can get it to you. So we did 5 examples. So if I come back up here again to that table we are looking at, there was 1, 2, 3, 4, 5, 6, 7. There's um, 8 compounding periods. We didn't do all 8 of these. We just did 5, but they're all done the same way. So compounding periods. So the I value is going to be the interest rate per year divided by the number of times per year is compounded. So you might be dividing by 1, 2, 4, 12, 24, 52, 26, or 365. You can be dividing by one of those numbers. And the n value, we're going to be multiplying the number of years by one of these values. 1, 2, 4, 12, 24, 52, 26, or 365. So it's important to remember this table. And if you can't remember all of them, then refer back to it or make a copy of the table, print. So you just have the table itself and then print a copy and set it next to you and your calculator as you're working out problems. When you're doing um, these, I've done lots of examples. The more examples you do, the better you're going to get at doing these. As they said, practice makes perfect. So if you follow the steps like I've laid them out, don't skip any steps. Do them exactly the way that I've done them for you here, or the way that they've been done in the lesson material that you receive for you. Okay, so follow the steps step by step. Don't leave any of the steps out, and you shouldn't make any mistakes. Calculators. There are many different types of calculators. So the exponent button may be different. It may be, as I said before, look like we call it a carrot, but it's the gable end of a house, almost like an upside down V, that sort of shape. If you have that button, that's the exponent button. Or you might have a button that says y to the exponent x or y to the power x. Now, in some calculators, to get to that button, you might have to use a shift key or a second function key. So there's many different types of calculators out there. What I would do, as I said earlier, is the examples that I've done for you online here, I would go through each one of these, especially the A equals P times 1 plus I to the power n. I would do each of those calculations on my own using the calculator that I have to ensure that I'm getting the same values that are shown on the screen. So if you're getting the same answer, the same solution, using your calculator, and you follow those steps all the time, then if you do 5 examples like I've done here, you'll get used to the procedure to follow each and every time, and then you just follow your procedure on your calculator each time to get to the solution, and then you know you're right. Another reason to do as I've done on the screen, where you show me your calculations for I, you show me your calculations for n, you show me the formula A equals P times 1 plus I to the power n, you show me the substitution, you show me the calculations, you show me I equals A minus P, the substitution, and then the answer. So if this might be worth, this question might be worth 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It might be worth 11 marks. I'm going to give you 1 mark per step. 11 steps. If you get the correct answers, you get all 11 marks. But if you don't get the right answer, let's say you do a miscalculation in the A part and you get the wrong answer, but you've shown me your work and you made a mistake, maybe a calculator mistake, then I'm only going to deduct 1 mark and I'm going to give you 10 marks for the rest because everything else was done correctly, even though the interest amount will be wrong now, but because this amount was wrong and you put over here incorrectly, but you did the right procedure and the answer would have been right if this value was right, then I'm going to give you full mark for that as well. I'm going to only deduct a mark for that one little error that you made there. Now, if you don't show me your calculations for I and your calculations for N, and they're not correct in here, then I don't know where you made your mistake. If I don't know where you made your mistakes, then I don't know what you've done, and then I can't give you any marks. So if you lay out your solution, like I've done here, step by step, you make one little mistake, you'll lose one little mark, and you'll get 10. So you're still going to get 90, 95% on the question, as opposed to maybe getting only 1 or 2 if I don't know how you did your calculations. Okay, so keep that in mind. Show as much work as possible. So that is as far as we are going to get today. So again, we've done 5 different problems, 5 different calculations. So now you should be good to work on your key questions. So if I come down here, we'll do a review tomorrow. We'll do some more problems tomorrow, but now you should be able to work on, get down to the end. Do your support questions first. Okay, so you can do, yeah, pretty much any of these questions here now involving compound interest. That's as much time as we have for today. Thank you for participating in the class, and I look forward to talking to you again tomorrow. Bye for now.